All right, welcome to 10.6, and in this section we're going to work on solving with radical functions, okay? So here, in order to get to the 3x, I have to get rid of the square root. In order to get rid of the square root, well, what's the opposite of the square root? Well, that's square. So I'm going to take this side, and I'm going to square this. And if I square that side, I have to square this side. So then I would have 3x is equal to 144. Then I'm going to divide both sides by 3, divide both sides by 3. Therefore, x is equal to 48. Okay, so then you would throw that back in to check. So is the square root of 3 times 48 equal to 12? And is the square root of 144 equal to 12? And yes, that checks. Then you move, let's look at something like this. Can I ever take the square root and have it equal to a negative number? And the answer is no. You can never take a square root or a fourth root or a sixth root. Any even root can never equal a negative number. So this one's kind of a trick answer. So this one has no solution. Before you even do the math, you should be able to determine this. Now, if this had been the cubed root, you could do this, but in this particular instance, it's not. Okay, so this is a no solution. And that's why you might want to check, because you will get something in here that would be a negative, and you can't take the negative square roots in there. Okay, now you might get something like this. Okay, your goal is always to get x by itself, so the first thing I would do is subtract 4 from both sides. Then I'm left with the cubed root of x plus 1 equals 4. Okay, and in order to get rid of a cube root, the opposite of that is cube. So therefore I get x plus 1 equals 64. Subtract the 1, subtract the 1. Therefore I have x is equal to 63. And then I go and check this is the cubed root of 63 plus 1 plus 4 equal to 0. And right off the bat, I have an error, and I have found it right here. So that's negative 4. That would be negative 64. And this number should have been negative 65. So in here, I should have negative 65. So it's the cube root of negative 64 plus 4 equal to 0. Well, the cubed root of negative 64 is negative 4. So is negative 4 plus 4 equal to 0? Yes, so that checks. All right, what about this? Okay, well again, I'm going to come in, square that. This whole side needs to be squared, okay? And so that's 54 minus x. Now this is not x squared plus 4. Remember, when you square this, this is like x plus 2 times x plus 2. Or if you can remember the rule, which I'm going to use, which is a squared plus 2 times a times b plus b squared. So then I have x squared plus 2 times x times 2, which is 4x. And then 2 squared is 4. Gives you that. Now, in order to be able to solve this, I'm going to add x to both sides and subtract 54. I'm going to set the equation equal to 0. So therefore, I will have 0 is equal to x squared plus 5 minus 46. Okay, this is where I'm going to pot it up. I got x and x. I need a plus and a minus. I have 1 and 46. I have 2 and 23. And I'm going to guess I made a mistake somewhere because that doesn't factor. Nice. That should be at 5x. And I'm not seeing what I did wrong. So I may have to come back on another video. But from here, you would be able to solve for x when you factor this out. For some reason, this is not factoring out, so I'm not sure. I probably copied this problem down incorrectly. So I'll make another video with a correct problem. Here you go. Here's another one. You might get something that looks like this. So you will go to the 5th power. If you 5th power that side, you get the 5th power of this. Popping out, that would be x plus 8 equals 2x minus 1. Subtract x plus 1 plus 1. Therefore, I get 9 is equal to x. And I would need to plug those both in and check. What about something like this? Remember Pythagorean theorem? A squared plus b squared equals c squared. Okay, I'm going to make 5 my a, so I'll have 5 squared plus b squared. This is my b, this is my unknown, equals 9 squared. So I will have 25 plus b squared equals 81. Subtract 25, subtract 25. So I'll have b squared is equal to 60, 50, 56. There, 81 minus 25, 56. Square root both sides. And then, so b is equal to, well, let me take my 56 and factor tree. So that is 2 and 28. That gives me 2 and 14 and 2 and 7. Okay, so that's the square root of 2 times 2 times 2 times 7. That's my twins, so b is equal to 2 square roots of 2 times 7, which you should finish it off as 2 square roots of 14. Okay, so this is giving you an application type problem with radicals. Email me or ask me in class if you have any questions.